This presentation is an introduction to the Utility Analysis and Improvement Methodology, or UAIM. UAIM is a key part of the LIFT for Management project, which is sponsored by the Water Research Foundation. The project manager for WRF has been Fidan Karimova. I'm Chelo Itasovich, the principal investigators. The two key people that made a significant contribution also are Mike Barnett from Smart Cloud and Scott Haskins as the KPIs of the project. The project advisory committee includes James Horn, Greg Ryan, Andy Cricken, Aditya Ramamurthy, and our consulting partners were CH2M and EMA. The critical success factor on this research project is the active participation and the contributions made by the water sector utilities, our utility partners, listed in this slide. They ensure that our focus and our efforts remain grounded in real needs of water sector utilities. Key deliverables on this project include a water sector value model that documents how utilities generate value, a methodology for improvement performance that includes a framework, and the third important deliverable of this project is a collaborative community of utilities and consultants who work together to identify and solve problems associated with utility management. The mission for this project is to develop and apply a holistic analysis framework and a methodology based on business process models to help utilities improve maturity of their capabilities and implement change management focused on value and overall performance improvement. This statement is admittedly a bit complex. In the following slides, we will break it down and demonstrate how each component of this vision is addressed by different aspects of the project. The project's overall focus is on value and overall performance improvement. In order to manage value, it is important to first define what value means. Our utility partners jointly defined the key elements in the value chain applicable to water sector utilities. This value chain shows what we are expected to deliver to our customers. The different things that we do, all the business processes that utilities execute, should in some ways impact these value components. In order to monitor and manage performance, we also need to define the key performance indicators that reflect the creation of value. A number of KPIs have already been defined by other research efforts, such as effective utility management or AWWA, utility benchmarking initiatives. LIFT for Management starts from this overall concept of value, the what, and then explores the how of value creation. Utilities create value by doing things. They execute many different business processes. We can divide the business processes into three major groups based on their time constant. On the operational level, business processes are executed and the decisions are made in real time. Examples include real-time monitoring and control. On a tactical level, the processes are executed on relatively short to medium term with the time constant measured in hours, days, or weeks. Utilities also execute strategic business processes that have a longer time constant, including processes and decisions that are measured in years. Business processes are executed by different business units within a utility and by staff and management who have different skills and focus. Even though this slide includes only a few of the many processes that are executed within a utility, we can see that managing a utility is not simple. The complexity and difficulty of coordinating different business units executing different business processes has sometimes led to practices that are disconnected and technical solutions that are described as silos or ingest as cylinders of excellence. In order to better understand how the value is created and to analyze ways to improve performance, it is useful to establish a framework that helps us consider these complexities within a holistic conceptual view. This is a conceptual model, a holistic framework for describing how a utility functions. It uses people, processes, and technology to accomplish work on different levels. This framework provides us with a map that spans across the entire organization and helps us navigate these complexities. Here are some examples of business units, processes, and technologies on these three levels. With this many moving parts, there are many ways to fail. However, in general, the model reveals two categories of failure. The first category are failures that occur within a single box, the deficiencies in any one of the processes, people, teams, or technology. The second category of failure is due to the lack of effective interaction between the different boxes. For example, if the design process does not include input from staff who operate the system or maintain the equipment, or if technology does not properly or fully support a process. The framework shows us how value is created in a utility. We will start by focusing on the middle column, the business processes. UAIM uses business process modeling to document, understand, and analyze how the work gets done. This documentation, the business process models, are the foundation of our improvement methodology. Business process models are organized in a hierarchical structure. In addition to the water sector value chain, at our first workshop at LIFTLink 2016, utilities also defined 6 business processes that are at a top level of a hierarchy for a water sector utility. At this top level, processes are represented as generic value chain elements that do not include detail. They represent what utilities do and not yet the detail on how they do it. As we structurally decompose and build out the hierarchy downwards, the details of the how will be included in the lower levels of the hierarchy. After the team defined this top layer during the following 10 months of the project, the utilities worked on developing business process models on the lower levels of the hierarchy. As we move down the levels of hierarchy, models include more specific detail and describe the workflow, data flows, decisions, metrics, and technologies that enable the execution of work and the decision making. Different utilities were developing different parts of the model. For the overall model to have maximum value, it is critically important that all these detailed models are consistent and that they share a common notation. Utilities were thus all adopting the same standard language and notation to describe the processes. Note that the lower levels are labeled as BPMN, which stands for Business Process Model and Notation. BPMN 2.0 is specified by ISO IEC 19510-2013 as a standard for documenting, analyzing, and improving business processes. This slide summarizes the symbols and the syntax elements used in BPMN diagrams. This standard enables us to produce rigorous and consistent documentation of business processes. This notation was adopted, and we are using a business process modeling tool called Signavio for this project. If the notation looks complicated or business process modeling sounds like a fancy term describing something that is complex. Let's remember that we are using a standard notation simply to document how we perform our work. We already know what we are doing, and modeling allows us to describe it in a standard and consistent format. This is an example of a business process model that was developed by Orange County in BPMN 2.0 format. Using a representation called swim lanes, the model documents which business units are involved in the execution of the process. The activities within a swim lane are performed by the same business unit. Activities are represented as boxes with rounded corners, and the sequence of their execution is indicated by arrows between them. Please note that some arrows cross the lines between swim lanes, showing how portions of the work are executed by different business units. The model also documents the decisions that have to be made, who needs to make them, and describes how decisions impact the different paths of executing the work. The model also shows how and at which points work activities are supported by different information systems. In this case, systems that support this process include the Computerized Maintenance Management System, CMMS, Geographic Information System, GIS, and the CIP database. While a business process may include actions by different business units, some value functions include a number of different business processes. An example here shows how different business units, Chief Financial Office, Water Resource Management, Engineering, and Water System Operations, can take different roles in business processes that are associated with different elements of asset management lifecycle. An overall business process model can help us document these processes, arrange them in an appropriate hierarchy, and identify the interactions between them. This type of a map can help us integrate these processes and technologies. For example, we may discover that information from asset monitoring, for example from SCADA or DCS, may be useful for decisions on maintaining, disposing, or designing new assets. Phase 1 of this project produced the first version of the model. The model is not yet done. The vision is that it will continue to evolve in the future as new models will be added and existing models may be revised. On the lower, more detailed level, different versions of models may exist for a specific process, reflecting different conditions. For example, different versions for a small or a large utility. As shown on this slide, business process models can describe what we do now or what we want to do in the future. This project introduces a standard method and notation that provides a structure for a dialogue and collaboration, both among internal stakeholders within one utility, and also a mechanism for collaboration among other utilities in the water sector who have adopted the same standard. Let's define another fancy term from the mission statement and explain what it means to improve the maturity of an organization's capabilities and how we can use the business process models to help achieve that. CMMI developed a conceptual model that includes different levels of capability, maturity, and organization. The key difference between these levels is how an organization gains, manages, and uses knowledge. Please note that within an organization, different business processes in different business units may be at different maturity levels. The left column represents level 1, labeled as initial. At this level, the knowledge about the execution of business processes resides in specific individuals who solve problems and just get the job done. A lot of knowledge is also classified as institutional, meaning that it is not really written down anywhere, but folks who have been there for a while consider it to be intuitively obvious. This level may be sufficient if the workload or the conditions do not change much. However, many of us know that such capability cannot be easily scaled up, and that the go-to staff may be stretched thin and or eventually retire, leading to difficulties in performance or succession. Second column from the left is level 2, labeled as managed. On this level, the knowledge and the skills required to get things done are shared and reside in disciplined work units, teams. On this level, managers can rely on teams and are better able to adjust the work to the changing demands and meet the commitments to other business units and customers. However, on this level, the work is still not well documented, and there may be issues with succession if the composition of the team experiences sudden or significant change. The third level is labeled standardized, and on this level, processes and practices are documented and standardized, and the metrics are defined. The knowledge about how the work is executed resides in the documentation that is accessible to all. The documentation may have different forms, formats, and notations. It may consist of narratives describing standard operating procedures, or it may be in the more advanced form, such as business process models. The development of documentation, even to only describe the as-is condition, enables us to elevate the maturity of our capabilities from level 2 to level 3. The process of collaboratively developing the business process models is very beneficial in itself, as all the stakeholders are learning and the knowledge is transferred from different heads to a diagram that all the stakeholders can look at and understand. Although individuals may master their own specific business responsibilities and activities, the process of modeling and mapping the flow of work and information between different activities and business units, especially when done in facilitated workshops with all the participants and stakeholders, can be quite illuminating for all. Level 4 in the capability maturity model means that our processes are managed quantitatively based on established metrics. The development of business process models includes defining the metrics, either adopting the ones that have been established before by other initiatives, such as effective utility management or AWWA, metrics and benchmarking research, or defining new metrics. In Phase 1, the project team focused on documenting the processes and developing business process model. In Phase 2 of our project, we used the business process models for analysis and to make improvements. Our goal was to leverage the models in order to raise the capability maturity of specific processes to level 4, where work is managed based on measurements. In Phase 2, utility partners conducted independent efforts to apply the UAIM methodology to a specific process that they saw as an internal priority. In other words, they were interested in documenting and improving these processes anyway, and the project provided a method that could be used. Each utility partner selected the process, they are listed on the slide, and they applied the same methodology. The project team provided guidelines and technical support. However, it was the utility staff that performed the work. The methodology included 5 steps. starting with documenting the existing as-is process using the standard notation BPMN. Each of the utilities developed these models independently. Development of the model included internal interviews and discussions among different business units and stakeholders. The second step was to conduct a facilitated workshop for all the stakeholders to discuss and jointly identify improvements to the as-is process. Examples of changes included streamlining the workflow, introducing automation, and other improvements. Although BPMN diagrams of the as-is process may be used as a reference in such workshops, the workshop would typically not include direct use of the diagrams, but will rely on simpler methods such as sticky notes on the board and to collect information that could be used later to prepare a model, a detailed BPMN diagram. After the workshop, the internal staff leading the improvement effort would develop the detailed diagrams of the new to-be process to capture all of the ideas for improvements that came from the workshop. The project team supplied business process modeling experts to provide technical assistance to make sure that modeling rules and best practices were followed. However, it was the internal utility staff who took the lead on defining and resolving the issues in the business domain, the specific processes in their utility. Once both the as-is and the to-be state were documenting, internal staff prepared plans to implement the improvements to close the gap between the existing and the desired. The project team developed and provided guidelines and technical assistance. However, it was again the internal utility teams that were best informed about the internal conditions and requirements and best able to develop a realistic plan. The last step in the methodology was to implement the changes and assess the impact of improvements. Not all the utilities were able to complete their case studies and execute this final step due to the constraints of the project schedule. However, the work will continue and the plan changes will be implemented as the project goes on into phase 3. One of the useful features of business process models is that we can assign resources such as equipment or staff time to activities. If we apply these resources to both as-is and to-be models of the process, we can simulate the impact of proposed changes to the business process. This is an example of analysis that was performed by City of Grand Rapids staff as part of their case study, showing the impact of proposed changes. This also illustrates how models can be used to move towards metrics-based performance measurement. Improvements to the individual processes and the impact on the specific metrics that are part of the modeled process can be rolled up to the key performance indicators, therefore connecting the local improvements to the overall value chain and utility performance. The most advanced level 5 of capability maturity is innovating, found in organizations that are engaged in continuous learning and improvement. Innovations are based on planning and analysis and implemented through change management. Rather than an event, innovation is itself a continuous process. Such improvements are implemented through successive change management efforts. At this point, this project did not include efforts to move to the highest level of capability maturity. Although business process modeling and metrics enable us to plan the improvements, moving to this level requires additional types of changes. As we consider continuous improvement and change management, our UAIM framework reminds us that the execution of work, the processes, include people and technology. Although business process models can identify who is involved, for example by indicating the swim lanes, so far we have only scratched the surface of the people aspect. The importance of the people aspect and issues related to the organizational culture have long been recognized and cannot be overstated. The quote from Peter Drucker speaks volumes to the importance of culture, which so far has not been addressed by the current scope of this project. As we look at the people aspect, we can see that to execute the business processes and create value, people across the organization interact with each other to get things done. The organizational structure and culture will determine whether interaction will take the form of collaboration. The best results are achieved when the goals of the individuals are aligned with the business goals of the organization. In order to achieve this, we may look at each of these culture aspects. The level of an individual, culture impacts how individual will make decisions, take action, perceive and deal with conflict, reach agreement, interact with other individuals, and perceive organization's culture. The organizational culture is defined by how an organization defines and measures success, defines rules for decision making, views conflict and disagreement, defines rules for power dynamics, defines the dominant mental model, measures and rewards success of individuals, deals with failures, and how it perceives its own culture. The UAIM framework and the associated methodology do not at this point include a thorough and significant scope to address the complex issues related to the culture, organizational and individual. We are following a change management method that includes facilitated workshops and active engagement of stakeholders, and we are conducting work with the existing organizational structure and culture. Efforts to change the organizational culture, as important as they may be, are not currently part of the project scope. The project team did provide guidelines for change management shown on this slide that provide practical steps to successful implementation without delving into the complex issues of culture. Such issues we may examine in Phase 3 of this project. To summarize, Phase 1 delivered the water sector value model, and Phase 2 delivered case studies for improvement and the guidance documents. In January of 2019, we will start work on Phase 3 of this project. Phase 3 will include 2 concurrent tracks. On Track 1, utilities will continue their individual efforts to document and improve business processes. They will select those processes again based on their own internal priorities. This track will also include the curation of the overall water sector value model, development of training materials, and continued support for utilities engaged in the modeling and improvement efforts. This phase will also develop a web portal. The portal will host all the content related to the project. Users will be able to access and browse the overall business process model that will include all the contributions from participating utilities, download case studies or a specific business process model that have been developed and posted by others, and post their own content. This will provide a vehicle for exchange of ideas and practices among participating utilities. As part of second track, utilities will form groups who will work collaboratively to develop best practices for area of common interest. They will define a few of such areas and work collaboratively to apply the UAIM methodology and the documentation in business process models. The deliverable of this effort will be the documentation in the form of business process models and associated narratives that will describe the best practices as jointly defined by a group of utilities. Both tracks 1 and 2 will continue to use business process modeling to define and describe how the work is executed. And both tracks will use the portal on LIFTLink platform as the main repository for all project-related materials and deliverables. We will be finalizing the current work on phases 1 and 2 by the end of 2018, and in January of 2019 we will start Phase 3, projected to last 2 years. Our team for Phase 3 includes utilities who participated in Phases 1 and 2 and chose to continue, and additional utilities who have joined for Phase 3. The project team includes KPIs, Mark Poling from Clean Water Services, Scott Haskins from Jacobs, and Mike Barnett from Smart Cloud. I'm Chelovi Tasovich with 9D Analytics. To find out more about this project or to join us on our mission, please use the contacts on the screen, or you can contact any of our participating utilities or partners. Please note that the project itself is a collaborative and continuous improvement effort, and each individual contribution from a utility grows the scope of our common overall knowledge base. Through active engagement of utility and consulting partners, we are tapping into the greatest source of expertise in the water sector. In a way, we are crowdsourcing the innovation in the water sector and making the accumulated knowledge contributed by utilities shareable among their peers by implementing a rigorous and standard, consistent notation and framework. I thank you for your attention and interest.